we have already seen how to do the root 3 and root 2. Now we are going to find out how we are going to do this one. That is, we have to show that 5 minus root 3 is a irrational number. So this first step is similar to the previous one. So we are going to assume. Let's assume what we are assuming. We are assuming that 5 minus root 3 is a rational number. Is rational. So that means we can find two integers, or we can say we can find coprime A and B, where B is not equal to 0. Now we can write that such that here what we can write, 5 minus root 3 is equal to A by B. Okay, so that means 5, therefore 5 minus A by B is equal to root 3. We can do this. So here we get root 3 is equal to 5 minus A by B. We can cross multiply this and we will get 5B minus A by B. We are getting root 3. Now, since A and B are integers, what we can say? Okay, since A and B are integers, if you look here, root 3 is equal to 5B minus A divided by B. So we can say that we get 5 minus A by B is rational. Yes or no? So this part is not necessary, okay? We are only using this. So if A and B are integers, we can write 5 minus A by B as a rational number. It's possible. A and B are integers, so we are subtracting only an integer from, A and B are integers, so we are subtracting it from 5, the rational number. So if 5 minus A by B are rational, then we can say that root 3 is also rational. It's the other side of the equation. So root 3 is rational. So if root 3 is rational, okay. So what we are getting here, we are getting that if you look here, we have A and B. Both are integers. So it's more like P by Q, where P and Q are integers and B is not is equal to 0. So obviously it's a rational number. So when we subtract this from 5, we are only getting another rational number only. So that means this side of the equation, it's a rational number. So obviously root 3 should also be a rational number. So that's why we are writing this. Okay. If 5 minus A by B is rational, then root 3 should also be rational. That's the logic. Now, but we know that root 3 is an irrational number. So this contradicts that the root 3 is irrational. This contradicts that root 3 is irrational. Okay, this is a contradiction. Why we are getting this contradiction? Because our assumption is wrong. As our assumption is wrong. Okay, so that means 5 minus root 3 is rational is a wrong statement. So we have to write that. Hence, 5 minus root 3 is irrational. I hope the steps are clear for you. So what we did, we assume A and B, two numbers. Okay, first obviously we are assuming it to be a rational number. Then we take A and B, two numbers which are co-prime. So 5 minus root 3 is equal to A by B. But 5 minus A by B is equal to root 3. So here when we analyze, we can say that the left hand side of the equation, it's a rational number. So 5 minus A by B is a rational number. Then root 3 should also be a rational number. But we know that root 3 is an irrational number. So this is a contradiction. So this is because our assumption is wrong. So hence 5 minus root 3 is a rational number. So now moving to the next question, we have to show that 3 root 2 is irrational. Again the same steps, that let's assume, let's assume that 3 root 2 is rational. Okay, when we assume that 3 root 2 is rational, we should find out two numbers such as a, let A and B are coprime, where B is not equal to 0. Then we can say such that 3 root 2, we can write it as A by B. Okay, that means root 2 is equal to A by 3B. Okay, since here we can say, when you look at the right hand side, since A, 3 and B are integers, what we can say? We can say that A by 3B is a rational number. Is rational. If they are rational, so we can say that root 2 is rational. But we know from theorem 1.3 that root 2 is irrational number. But this contradicts the fact that root 2 is irrational. Okay, so that means our assumption is wrong. Hence 3 root 2 is irrational. Okay, I hope this is clear for you. So what we did, okay, next we have to prove that root 5 is irrational. So we are going to follow the same steps like the previous questions. So like we have proved root 3 is irrational, and like root 2 is irrational, we are going to prove root 5 is irrational. So to start with the same, that is, we have to assume that root 5 is an irrational number. So let's assume that root 5, sorry, root 5 is rational. Now if it is a rational number, then therefore there are A and B are integers which are not equal to 0. Okay, B is not equal to 0. Okay, such that we can write such that root 5 is equal to a by b. Okay, now if root 5 is equal to a by b, then we can say that now we assume that a and b are co-prime. Now if they are co-prime, we can say a is equal to root 5 into b. Okay, so now squaring on both sides, what we get, a square is equal to 5b square. Let's call this equation number 1. Now if a square is equal to b 5b square, that means we can say therefore a square is divided by 5. That means we can also say that 5 divides a by theorem. In brackets you can write theorem 1.3. So this you can either write it as 5 divides a, or you can write a is divided by 5. Both are same. Okay, so now we are going to assume let a is equal to 5. Either you can write it as 5c, or you can use another another integer k. You can use any of this, c or k, both are fine. So here I'm just showing you how to use this. So if a is equal to 5k, where k is an integer, okay, so we are getting a is equal to 5k. So now on squaring both sides, sorry, on substituting, what we are getting, we are going to substitute this a is equal to 5k in equation number 1. So when we substitute, we get 5k the whole square is equal to 5b square. So that means 5k square is equal to b square. This means 5 divides b square. So 5 divides b square. So that means 5 divides b. So that means what we can say that a and b have a common factor 5, because 5 can divide a and also 5 can divide b. So that means a and b have 5 as common factor. So if 5 is a common factor, that means this is a contradiction. To the fact that a and b are coprime. So if this is a contradiction, that means our assumption is wrong. So hence root 5 is irrational. So it's a hence proved. So it's the same method. Okay, you will understand if we do one more question. So now next we have 3 plus 2 root 5 is irrational. We have to prove that. Okay, don't worry about these numbers or the expressions. Just follow the same steps. So first of all, let 3 plus 2 root 5 is rational. Okay, so let it be a rational number. Now we can find two co-primes, two co-prime integers a and b, where b is not equal to 0. Okay, now such that what we can write it in the form of a rational number. So 3 plus 2 root 5 is equal to a by b. So that means 2 root 5 is equal to a by b minus 3. Now what we can do, we can write root 5 is equal to 1 by 2 into a by b minus 3. So this is what we are getting. So now if you observe both sides, left hand side and right hand side of this equation, what we are getting, since we can say that since here we have a, b, 3 and 2 are integers. If these are integers, what we can say, it will be a rational number. So half of a by b minus 3 is rational. So then we can say that therefore root 5 is rational. But we know for the fact that this contradicts that root 5 is irrational. So this contradicts that root 5 is irrational. So our assumption is wrong. Which assumption? That our assumption that 3 plus 2 root 5 is rational is wrong. So we can say that hence 3 plus 2 root 5 is irrational. Okay, so that's about our second question. Now moving to the third question, we have three sub questions: 1 by root 2, 7 root 5 and 6 plus root 2. So let's start with the 1 by root 2. We have to follow the same methods only. So starting with the sub question 1. So let's assume 1 by root 2 is rational. So if it is rational, therefore we can find 2 co-primes, 2 co-prime integers. Okay, so we can find 2 co-prime integers such as a comma b, where b is not equal to 0. Now such that we have 1 by root 2 is equal to a by b. So this we can write it as root 2 is equal to b by a. Now this means, so here b by a is rational. Why we are writing it is a rational number? Because a and b are integers. As a and b are integers, they are only integers, so it's possible it is a rational number. Then we can say that therefore root 2 is rational. If one side of the equation is a rational number, then our other side of the equation should also be a rational number. But which contradicts that our assumption, which contradicts the fact that root 2 is irrational. We already seen that root 2 is an irrational number. So hence our assumption is wrong. Our assumption is wrong, or you can write false. So 1 by root 2 is irrational. Okay, now we are going to use the same method for 7 root 5. So that's our second sub question. I hope the first sub question is clear. So we are going to write let 7 root 5 is rational. Okay, if it's a rational number, we can find two coprimes, or we can say two coprime integers, a and b, where b is not equal to 0, such that we can write 7 root 5 as a by b. Now we can write root 5 is equal to a by 7b. Okay, our goal here is to isolate the irrational number alone and equate the other numbers to the right hand side. So that's what we are doing in all these questions. So now a by 7b is rational as a, b and 7 are integers. Okay, now so then we can write therefore root 5 is rational, but this contradicts our assumption. Sorry, this contradicts the fact, not our assumption. This contradicts the fact that root 5 is irrational. Okay, now so that means our assumption, therefore our assumption is false. So hence we can say that 7 root 5 is irrational. Now that's about our second sub question. Now moving to the third sub question. So for third sub question, we have to prove that 6 plus root 2. So let 6 plus root 2 is rational. Now if it is a rational number, we can find two coprime integers. We can find two coprime integers a and b, where b is not equal to 0. Now such that we can write 6 plus root 2 is equal to a by b. Now we have to isolate the root 2. So root 2 is equal to a by b minus 6. Now since a, b and 6 are integers, we can say that a by b minus 6 is rational. Okay, if the right hand side is rational, then therefore root 2 is rational. Okay, if root 2 is okay, so that this contradicts the fact that root 2 is actually irrational. This contradicts that root 2 is irrational. So our assumption is wrong, and hence we can say that 6 plus root 2 is irrational. So hence we proved. Now these are the exercise question from real numbers. I hope this is clear. So what you have to remember is the structure of this answer. Okay, first we assume, then we find two integers a and b which are co-prime, and we represent 6 plus root 2 is equal to a by b. Then we rearrange them. We are taking irrational number to the one side and the other integers to the other side. So then we can easily say that the right hand side is rational. If the right hand side is rational, we can say left hand side, that is root 2, is also rational. But this is a contradiction, so our assumption is wrong, and 6 plus root 2 is irrational. I hope these questions are clear for you. So if you have any doubts, you can ask me in the comment section. Thank you.